aware there's a perception in the market that all thermal blocks are much the same. And there's a belief that if there's a particular thermal block specified on a plan, then another thermal block can be used in its place. We know this is a practice that has been used across sites in Ireland, and one can be very costly in the building performance and in fact even its compliance with building regulations. The fact is the thermal blocks are not all the same. They are in fact very different, and we're going to show you today why the main thermal blocks in Ireland are so different. So let's look at the two main thermal blocks on the Irish market. The lightweight aggregate block, which is a number of different manufacturers in Ireland, and the aircrete block from Quinn's, the only manufacturers of aircrete blocks in Ireland. There is an option to use a cellular glass insulation block, but this has a maximum compressive strength of 2.9 newtons per millimetre squared. And the requirement set out by Technical Guidance Document A of the building regulation stipulates you need a minimum compressive strength of 7.5 newtons per millimetre squared. So unless you use the services of a structural engineer to prove adequacy of a certain project, which can be costly or time consuming, this block cannot be used. Immediately we can see there's a vast difference in appearance in the two blocks. So this makes them quite distinctive and easily recognisable. We can see from the variety of different lightweight aggregate blocks that they differ in appearance, but they all have very similar properties. The Quinn Lite block is very distinctive in its smooth surface, and as you can see, it has got very tiny air pockets, which is a very important feature. But it's the difference in performance that the Irish construction industry needs to be aware of. Each of these blocks have the same strength, and they both meet the requirements set out in the building regulations, as they are both 7.5 newtons per millimetre squared. As they are both the same strength, some people have made the assumptions that if one is specified on a plan, then it can be substituted for the other on site. But the makeup of the blocks and the manufacturing process are very different, resulting in very different thermal properties. The Quinn Lite block is vastly superior in its thermal properties, and it can achieve up to 200% better psi values than the lightweight aggregate block. Therefore, if the Quinn Lite block is specified on a plan, it should not be substituted for a block of inferior thermal performance on site. Substitution on site could lead to non-compliance of building regulations, given the substantial difference in the thermal performance of each of the blocks. And with new NZEB regulations coming into effect, this should be given greater consideration, and one that architects, assessors, and indeed all construction professionals should be made aware of. The difference between a lightweight aggregate block and your standard dense concrete block comes from the aggregates that is blended together in the concrete mix. Your standard dense concrete block uses more dense aggregates such as limestone and other dense aggregates, whereas your lightweight aggregate block uses lightweight aggregates such as pumice, expanded clay and litag. The manufacture of the Quinn Lite thermal block, on the other hand, is a much more complex process, and is made up of raw materials that are not included in the lightweight aggregate block and the standard dense concrete block. The Quinn Lite block is made up of 80% recycled materials. It's made from a blend of cement, pulverised fly ash, silt, thickened sand, aluminium and lime. The manufacturing process of the Quinn Lite block is vastly complex, and we are going to show you this now. Thickened sand mixed with silt, water and recycled material from previous batches. The dry ingredients fly ash, cement and lime are then added and mixed for approximately 90 seconds. Powdered aluminium is combined with water to create a raising agent, which is added to the mixture at the end of the mixing process, and mixing continues for around 30 seconds. The precise quantities of each ingredient required is dependent on which Quinn Lite block is being manufactured, as each ingredient adds unique properties to the finished block. What we now call the cake mixture is poured into large oiled moulds and transferred into a pre-curing chamber, where it remains for a period of 2 to 2.5 hours at an ambient temperature of 32 degrees Celsius. During this period, a chemical reaction takes place between the aluminium and the lime. Like all chemical reactions, gases are formed during this process, which fills the mixture with millions of tiny pockets of air, causing the cake to rise between 70 to 170 millimeters. It has these tiny pockets of air which gives the blocks its excellent lightweight and thermal properties. After curing, the cake is tested to ensure correct consistency, then tilted and removed from the mould. The cake is shaved to the correct thickness and individual blocks are cut using piano wires before imprinting with identification data to ensure full traceability. The leftover shavings are recycled and used in another mix to minimise waste. The cake is transferred to an autoclave to be steam cured in a very controlled environment. The temperature control within the autoclave requires a slow increase in temperature to reach 180 degrees, which takes several hours. The temperature is held at 180 degrees and then slowly declines. The process takes an average of 12 hours with precision temperature control throughout. During the autoclaving process, the blocks will achieve their full design strength. This differs for dense or lightweight aggregate blocks, which typically achieve the full strength after 28 days. Blocks are then separated and packaged. Samples from every batch produced are tested for quality control, with multiple tests carried out over a 48-hour period to ensure strength and thermal properties meet their specific requirements. So we can see from the appearance, the makeup and the manufacturing process that the thermal blocks in Ireland are very different. And given the variance in the thermal performance, we believe the superior Quinn Lite block should not be substituted for an inferior performing block when you get on site.